guys!
Hi guys! We're back again!
So in this video, we're going to show you how to solve a linear programming problem.
Using SIMPLEX method! SIMPLEX method is a standard method of maximizing a linear function of several variables under several constraints on other linear functions. In each iteration of SIMPLEX method, the primary algebraic task is to transform the constraints from a given configuration to a new configuration that corresponds to the next basic feasible solution. Such transformations are to be repeated many times in the course of the solution of the problem. It is therefore desirable to execute them in a manner that is as efficient as possible. For this purpose, we will now introduce a very compact way of representing an equation system. The idea simply is to present the coefficients of the variables and the constraints in the form of a table. An equation system presented in this manner is said to be in the tabular form. Since we are dealing with equations that arise during the execution of the simplex method, such tables will also be referred to as simplex tableau.
Our first problem is to solve the following LP formulation using the simplex method. Our objective function is z equals 24x sub 1 plus 28x sub 2 with the constraints 5x sub 1 plus 4x sub 2 less than or equal to 2000, x sub 1 greater than or equal to 80, x sub 1 plus x sub 2 greater than or equal to 300, x sub 2 greater than or equal to 100, x sub 1, x sub 2 greater than or equal to 0.
Before the simplex algorithm can be used to solve a linear program, the problem must be written in standard form. Constraint of type less than or equal to, each constraint of this type, we add a slack variable which will be denoted by S. Constraint of type greater than or equal to, each constraint of this type, we subtract a slack and add an artificial variable which will be denoted by minus S plus A. For constraint of type equals, each constraint of this type, we add an artificial variable.
The transformed tableau ready format equations is to minimize z equals 24 x sub 1 plus 28 x sub 2 plus 0 s sub 1 plus 0 s sub 2 plus 0 s sub 3 plus 0 s sub 4 plus m a sub 1 plus m a sub 2 plus m a sub 3. Our first constraint is x sub 1 plus 4x sub 2 plus s sub 1 equals 2000. Our second constraint is x sub 1 minus s sub 2 plus a sub 1 equals 80. Our third constraint is x sub 1 plus x sub 2 minus s sub 3 plus a sub 2 equals 300. Our fourth constraint is x sub 2 minus s sub 4 plus a sub 3 equals 100. This is our first tableau. As you can see, we just plotted the constraints above to the table. To find zj, we must multiply 0 and 5 plus m times 1 plus m times 1 plus m times 0. With that, we have 2m, and so on and so forth. Our next step is to find cj minus zj, which is 24 minus our zj, which is 2m, and so on and so forth. The next step we should do is to find the most negative Cj minus Zj, which is 24 minus 2m. Therefore, this is our pivot column. The next step we're going to do is to find the pivot row. First step we're going to do is to do the ratio test, which is to divide the quantity over the pivot column. So here are our answers. As you can see, the least number here is 80. So this is our pivot row. Since the pivot number is 1, the new row 2 variables stay the same. Performing the elementary row operation on rows 1, 3, and 4, we are given the formula. The formula we should remember is new row number minus number in old row minus number sign above or below the pivot number times the corresponding number in the new row. An example is x sub 1 in row s sub 1. So our old number in x sub 1 is 5. Our number above or below the pivot number is 5 times the corresponding number in the new row, which is 1. So our answer is 0. This gives us the second tableau, which is shown here. So we can see here the new values solved above here. So the next step is to find the Zj. So in finding the Zj, we just multiply Cj, these values, times the values here. So 0 times 0 plus 24 times 1 plus m times 0 plus m times 0. So we have the Zj of value 24. And same with all the columns. So we have 2m and 24m and so on and so forth. For Cj minus Zj, we just subtract the value of Cj here minus the value of Zj. So we have 24 minus 24 equals 0, 28 minus 2m equals 28 minus 2m, and so on and so forth. So same with what we've done in the first tableau, we just find the pivot number by first finding the pivot column. So here the pivot column is shown, which is the 28 minus 2m. So now since we already have the pivot column, it's time to find the pivot row, which is determined by doing the ratio test. So in ratio test, we just divide the quantity values by the values in the pivot column. So 1/6 divided by 4 is equal to 400. 80 over 0 is equal to undefined, so we just write NA. 220 over 1 equals 220, and 100 over 1 is equal to 100. So since 100 is the smallest value in among the quantity values in the ratio test, we now find the pivot number, which is the intersection of pivot column and pivot row, which is 1. Since the pivot number is 1, the new row 4 value stays the same. So performing elementary row operations on rows 1 to 3, we just use the formula used before, which is new row number equals number in old row minus the number above or below the pivot number times the corresponding number in the new row. Using the formula, we find the new values of row S sub 1. So x sub 1 equals to
the old value, which is 0, minus the number above or below the pivot number, which is 4, times 0, which is the corresponding number in the new row, which is 0. So 0 minus 4 times 0 is equal to 0. Same goes with the other variables.
As done in the previous tableaus, we should first determine our ZJ. So to do that, we multiply 0 by 0 plus 24 times 1, m times 0, 28 times 0, so we have a value of 24. And we do the same in the next rows. The next step we're going to do is to find the CJ minus ZJ. So CJ minus ZJ, ZJ minus ZJ, CJ minus ZJ, and so on and so forth. Column S sub 2 has the most negative CJ minus ZJ, which is 24 minus M. Therefore, this is our pivot column. To determine our pivot row, we must do the ratio test as shown here. As you can see, the least number is number 120, which is row A sub 2. Row A sub 2 has the smallest value in the ratio test, therefore it is now our pivot row. This gives us our pivot number, which is 1. We now substitute S sub 1 with A sub 2 as our new basic variable in row 3. Since the pivot number is 1, the new row 3 values stay the same. Performing the elementary row operations on row 1, 2, and 4, we use the formula to determine the new row numbers of S sub 1, X sub 1, and X sub 2. We use this formula. And as you can see, we already plotted and answered the new row numbers, which will give us our fourth W. As you can see, the CJ minus ZJ now only contains numbers greater than or equal to 0. Therefore, the fourth W is our final W and presents the optimal solution to the problem. As summarized, our optimal solution is Z equals $7,600. Our X sub 1 is 200. Our X sub 2 is 100. So that's it for today, guys. I'm Demi.
I'm Anna.
And don't
Forget
forget to
to
hit
thumbs
like.
up this video.